The only way to guarantee the survival of our species may be to create a new home off Earth. The amazing discovery of huge amounts of water has boosted interest in Mars, putting it in the spotlight. NASA and ESA, the European Space Agency, and private companies such as SpaceX are already working on projects for settlements on the Red Planet in the coming decades. But it won't be an easy road. Mars is so far from Earth that the spaceflight would be about 6 to 9 months, involving long exposure to cosmic radiation and zero gravity. We will also need to overcome the engineering difficulties of landing on Mars due to its thin atmosphere. That future colony on Mars will need effective shielding, as the ionizing radiation that reaches the surface is extremely hot and would be lethal.
The atmosphere is so thin that if you were not protected by a spacesuit and by accident you were exposed to the atmosphere of Mars, your blood would boil instantaneously.
All those difficulties make the construction of a permanent settlement on Mars a huge, unprecedented technological challenge.
This is a game where you have to do everything right and roll 7-11 or doubles.
Our descendants, who might live on Mars, will remember the moment they established the first space colonies as one of the greatest milestones of humanity. Since human being that is considered one of the best targets for possible human colonization, Mars. Its surface conditions and the presence of water on Mars make it the most hospitable planet in the solar system.
It's a red-colored rocky desert with a lot of sand, and we have that in many places on the Earth.
Like Earth, Mars has polar ice caps and clouds in its atmosphere. Seasonal weather patterns. 2007 made progressive discoveries related to evidence of past and present water in the geologic record that make it possible to take the next steps toward finding evidence of life itself.
I want to find out if there is alien life there. And of course not big aliens, tiny little microbes, because it would be the first example of an alien form of life that we would find. And Mars is a good place to go look for that.
In 2011, NASA's Curiosity rover marked a transition between the themes of follow the water and seek signs of life. In addition to landing in a place with past evidence of water, Curiosity was seeking evidence of organics, the chemical building blocks of life. The ExoMars mission, a mission of the European Space Agency, ESA, in collaboration with NASA and NASA's Mars 2020, will finally try to discover if there is or has ever been life on Mars by searching for life itself in places identified as potential habitats. Finally, the third phase of the NASA's Mars exploration program is to prepare for human exploration, be able to say that our path to the colonization of Mars will have started. Human beings' curiosity and passion for exploring new worlds knows no limits. We always want to go beyond our boundaries. The origin of this impulse answers the need of the species to find new habitats that encourage its development. Now, our next frontier is beyond the Earth. Space colonization is the next logical link in our evolution as a species. Beyond the Earth, there are a huge number of resources that we could benefit from to keep growing.
This is a way
that the human population
destruction by external causes or even self-destruction. The choice could be, as H.G. Wells said, the universe or nothing. Climate change has become a serious threat to our civilization, and we are already starting to suffer its first consequences. Another threat, the danger of an asteroid impacting our planet, is real, and depending on the size of the asteroid, the consequences could be catastrophic.
We have the probability that a big asteroid might hit the Earth, like it was done in the past when the dinosaurs died out.
It's not likely to happen tomorrow or even in our lifetimes, but it is definitely going to happen sooner or later, and so it would be best if we were prepared for that.
A permanent base beyond the Earth would guarantee not just an alternative home in case of need, but also access to a huge number of resources out there. Mars, due to its characteristics, is considered one of the best possible places for that future permanent base off Earth. Other places like the Moon or the asteroids are also considered possible targets when it comes to taking the first steps toward becoming a multi-planetary civilization. Several private companies are developing projects to extract resources and rocket propellant from asteroids. What is more, the discovery of water on the Moon has led to the development of concepts such as the Moon Village, proposed by ESA, the European Space Agency, to carry out activities based on the exploitation of resources and scientific research. Nevertheless, to establish a permanent colony that may become a future home for human beings, Mars offers several advantages over the Moon or other places. Mars is bigger than the Moon and also has more resources that we could take advantage of. So it's better suited to improvements to turn it into the home for a self-sustaining civilization. While the Moon has no atmosphere at all, Mars has the advantage of having some atmosphere, composed primarily of carbon dioxide, about 96%, with other gases such as argon and nitrogen, which means we can grow plants just by compressing the atmosphere.
Mars has water, frozen as ice, and permafrost in the soil, but nevertheless there in large quantities. It has carbon dioxide, atmosphere, which is carbon and oxygen. It's what we need to make fuel. It's what we need to grow food. Has nitrogen, which life also needs. These things are extremely rare or completely absent, for example, on the Moon.
If we compare our own planet to Mars, they are surprisingly alike in many ways. Conditions on the surface of Mars are closer to the conditions on Earth in terms of temperature and atmospheric pressure than on any other planet or moon.
The temperatures get to about 20 centigrade in the daytime at the equator, which is entirely acceptable. At night, it can get very cold, but it's not difficult to shield against cold by wearing a heated spacesuit. As different as they are from Earth, the conditions on the surface of Mars are acceptable for human exploration and settlement.
Mars, in comparison to the Moon, has gravity more like Earth's. While the Moon's gravity is 1/6 of the Earth's, Mars is 1/3. Thanks to studies done at the International Space Station, the only available laboratory of zero gravity, we know that the lack of gravity is a health problem in the long term. We suppose that having gravity much closer to Earth's will be favorable to settling a colony. A lunar day is 28 Earth days, whereas the Mars day is 24.5 hours, almost identical to Earth's. Also, Mars is about half as far again from the Sun as Earth is, so it still has acceptable sunlight. All these similarities between the two planets have led NASA in doses of radiation.
Mars doesn't have a magnetic field, so galactic cosmic rays get through the thin atmosphere, solar flares, some of that gets through, and it can disrupt the DNA. So you need a habitat that shields the astronauts.
The Mars Odyssey spacecraft measured this cosmic radiation. It found that radiation levels in orbit above Mars are 2.5 times higher than at the International Space Station. A 3-year exposure to such levels would be close to the safety limits currently adopted by NASA. The effects on living organisms have been closely studied. Protons from cosmic radiation may cause twice as much serious damage to DNA as previously estimated, exposing astronauts to greater risk of cancer and other diseases. NASA is exploring a variety of alternative techniques and technologies, such as plasma deflector shields, to protect astronauts and spacecraft from radiation. Nevertheless, a 100% effective technique has not yet been developed. Another of the main challenges when it comes to sending manned missions to Mars indicate that they will soon be able to reduce the costs of the trip considerably. But sending a manned mission to Mars would still mean solving very important questions, such as being able to make a safe landing.
Landing on Mars is tricky. First of all, you use an aeroshield to slow yourself down from orbital speeds to subsonic speeds, and then you pop a parachute, and that brings you down to a slow velocity, and then you have to then do the final.
NASA has also already started to study closely what the best location for our first home on Mars would be. These should be locations of high scientific value that would also provide resources to allow human explorers to live on Mars. Local natural resources such as water and oxygen are crucial for humans to explore Mars. Liquid water might be obtained from 3 sources: ground ice, which would be buried or beneath the surface, the atmosphere, or hydrated minerals. Oxygen, by comparison, can be generated from the carbon dioxide that makes up most of Mars's atmosphere.
There's a lot of disagreement about where the Mars base should be. The poles have an advantage because there's water ice there. But the problem with the pole is it's dark for half a Martian year, which is, say, almost a full Earth year. So that leaves you either with the equator regions or the mid-latitudes. They both have something to argue. The equator is the warmest, varies the least with season. But if you go to mid-latitudes, you can get places that always have at least some sunlight all year long, but which have some water ice too. Not big fields of it like the pole, but nevertheless deposits of water ice that are readily accessible.
My favorite site, we call it Noctis Landing, and it's in the western end of Valles Marineris, which is this giant canyon that cuts the surface of Mars. I love this location because it's at the bottom of the canyons, but at the same time it's in an area that's very wide and very open, so that you can see the Earth easily in the sky and maintain communication.
Other possible places considered for a first location on Mars are paradoxically outside the planet. They are the small moons Phobos and Deimos. The planet is called Mars Ice Dome, which was designed for NASA by the company's Space Exploration Architecture and Clouds Architecture Office. This ice dome would be built using the most advanced 3D printing techniques. The Mars Ice Dome is a large inflatable structure surrounded by a shell of water ice. Water ice is an effective shielding material for galactic cosmic rays, and many areas of Mars have it in abundance just below the surface. So water ice is a great solution for building habitats on Mars. The Mars ice dome structure is lightweight, so it could be easily transported and deployed with robotics, then filled with water before the crew arrives. Another interesting aspect of the Mars ice dome is that the translucency of the ice washes the habitat with daylight, connecting the inhabitants to natural diurnal cycles, and also lets them enjoy the views. Other construction solutions that involve burying the habitats before the crews arrive would require heavy robotic equipment that would need to be transported from Earth, which would make costs rise significantly. The Mars ice dome instead balances the need to provide protection from radiation without the drawbacks of an underground habitat. However, to make it possible for human beings to live in a hostile world like the Martian environment, we are going to need more than just a safe habitat. The colonization of Mars will also require a wide variety of equipment to provide services directly to humans, and production equipment used to produce food, water, breathable oxygen, and energy. This will need a reliable source of energy that keep the functioning constantly. In fact, a source of energy for the general supply of the colony will be another key factor.
The energy source for growing plants on Mars is going to be Martian sunlight. The solar flux on Mars at the equator is about the same as that on Norway on Earth. If you go to Norway, there are forests, there's plants grow there, and it's enough. It's enough light to grow plants. Now, of course, the human colony needs more energy than that, just as we need more energy than just outdoor lighting in the daytime, which we use to grow our crops here. And you have basically two choices at the first, which is solar energy or nuclear energy.
The issue with the solar energy on Mars is that it is not totally reliable. A sandstorm could reduce solar energy for months. For any kind of colony that we are able to settle on Mars, we will need to study the different options of communication with Earth, made difficult because of the huge distance between the planets. NASA and ESA included communications relay equipment in several of the Mars orbiters, so Mars already has communication satellites. While these will eventually wear out, additional orbiters with communication relay capability are likely to be launched before any colonization expeditions are mounted. The one-way communication delay due to the speed of light depends on how far Mars is from the Earth. This delay makes real-time communication, such as telephone conversations or internet relay chat, between Earth and Mars highly impractical due to the long time lags involved.
To Mars, it can be as short as around 4 minutes, or as long as 20 minutes. Once in a while, if Mars goes behind the sun, you can't talk to Mars at all.
This blackout could be solved by using a future network of communication satellites, which would be a realistic solution for a full colonization program. NASA kicked off the Mars mission program with the launching and testing of the Orion Multi-Purpose Crew Vehicle in 2014. The Orion is the first manned spacecraft intended to go beyond the low Earth orbit into deep space since the Apollo program. It has two modules: the Launch and Splashdown Crew Delivery Vehicle and the Deep Space Habitat Module, where the crew will live during the 16-month-long journey from Earth to Mars and back.
It's a good design. It was designed to be bigger than Apollo, so the crew could be a little larger. It's designed to have a multi-purpose destination.
The first manned Mars mission is currently scheduled for the 2030s. On this pioneer mission, the astronauts will be able to orbit Mars for the first time ever and then return to Earth. Therefore, on this first mission, no walk on Martian soil is planned. In addition to NASA, other space agencies have different plans for the future exploration of Mars. ESA, the European Space Agency, through the Aurora program, has a long-term goal for the robotic and human exploration of Mars, with the hope of finding traces of life. It has already sent robotic probes like ExoMars in 2016 and plans to send the next probe in 2020. India, Japan, China, and Russia also have different robotic missions to explore Mars to be launched in the coming years. China and Russia plan to send humans to Mars in the 2040 to 2060 timeframe, but they are still long-term plans that could vary in the near future. Therefore, the only national space agency that has the clear goal of sending humans to the Red Planet, Journey to Mars, that will culminate in a permanent settlement there. It has 3 different phases: Earth-reliant, Proving Ground, and Earth-independent. The second phase, called Proving Ground, will test the capabilities needed by future Martian pioneers to live on Mars through several missions operating near the Moon. This phase will last till 2030. In the first of these missions, the Orion spacecraft will travel without astronauts thousands of miles beyond the Moon for 3 weeks. The next step will be a similar mission, but with astronauts inside the Orion. In addition to different space agencies, interest in sending manned missions to the Red Planet, there are also several non-governmental organizations and private companies that have shown the clear intention of making the colonization of Mars.
We could be on Mars by the end of his or her second term.
One of the most advanced private projects which is considering a self-sustaining human colony on Mars is the SpaceX project. The Space Exploration Technologies Corporation, the so-called SpaceX, is an American aerospace company founded in 2002 by Elon Musk, Tesla Motors CEO, and former PayPal entrepreneur, with the long-term goal of developing technologies that will allow a human settlement on the Red Planet to become a reality. Their ultimate aim would be to create a self-sustaining community, not just an outpost, that could grow into a city. To achieve it, Elon Musk states that an essential condition is to radically reduce the costs of the trip. As with the present costs, it would be totally impossible. According to Musk, the key factors to achieving lower costs would be the full reusability of the rockets, refueling in orbit, and propellant production on Mars.
SpaceX started by proving that they could develop space hardware at 1/10 the cost and 1/3 the time of the mainstream aerospace contractors.
SpaceX's plan is to create a Mars colony with a sustained population of 1 million people, which would mean 10,000 trips there with 100 people per trip in a time frame of about 40 to 100 years. The spaceship is designed with a crew cabin on top and a cargo compartment underneath, with capacity for 450 metric tons of cargo per trip. The duration of the trip would be about 80 days at the beginning, with the goal of reducing trip time to 30 days in the future. If all the plans are achieved, we would be witness to the arrival of the first crewed flight to Mars in about 10 years' time. Until that incredible milestone is reached, the goal is to send cargo from the very first trips to Mars from now on.
Musk might be able to do it. He's going to have to be lucky, okay? He's very brave, he's very determined, but this is a game where you have to do everything right and roll 7-11 or doubles.
Thanks to unstoppable technological advances, the settlement of a Mars colony is no longer the realm of science fiction, but a feasible reality. In the coming decades, we might be landing, working, and living on Mars. This could be just the beginning of the interplanetary expansion of the human being in the solar system. Maybe in a not-so-distant future, our home will be in a very distant place, in one of those remote space colonies.